we're going to still talk about the distance between any two given points. So if I'm trying to find the distance between these 2 points, negative 2, 4, and 2, negative 3, obviously I'm trying to find the length of this pink line here. The distance is the straight line between the two given points, and I want to find the length of that line. So I'm going to just call it x here. So I'm trying to find the value of x. So I can, on a coordinate system, I can make a right triangle out of any two given points just by going straight down and straight over and making a right triangle. It's imperative that you see that this is a right triangle, and it doesn't matter. I could have gone over this way or down. Can you see that these two triangles are actually equal and they share the same hypotenuse, so that x value is going to be the same. It really doesn't matter if you go down and over or over and down. So the length between, this is on my y-axis, right? The length of this first line here. So that's going to be my y distance. So I'm going from positive 4 down to negative 3. So that is a distance of 7. And then on the x-axis, I'm going over from negative 2 to positive 2, and that is a distance of 4. So using Pythagorean theorem, because that's just a right triangle, I can say 7 squared plus 4 squared equals x squared. 49 plus 16 equals x squared. 65 equals x squared. And then I can take the square root of both sides, so I have the square root of 65 equals x. And I know I've been hounding you about doing positive and negative whenever you're the one doing the square root, but this distance cannot be negative. Distance is never negative, so I really only need the positive of the square root of 65. So now let's contrast that to the formula. There actually is a formula that you guys can memorize. It's one that we will use over and over again in this class, so do take the time to memorize it. So using these same 2 points, we have negative 2, 4, and we have 2, negative 3. So, and it really doesn't matter what I call these. Don't confuse these little subscript numbers, the ones down at the bottom. Those are the values of the x value and the y value of a certain point. They are not exponents. So please make sure you write them below so we don't confuse them with exponents. So I could say that this first one is 0.1, and this second one is 0.2. It really does not matter. I could have just as likely called this one 0.1 and this one 0.2. So of 0.1, I have an x value and I have a y value. So that's where the subscript comes from. And then for 0.2, I have an x2 and a y2. So now what I'm going to do is I'm just going to plug them into my formula up above. So I'm going to take the square root. So I want to take the x values. Notice that we're just subtracting the x values. So that's going to be negative 2 minus 2 squared. And I'm going to subtract my y values. So that's going to be 4 minus negative 3 squared. Well, negative 2 minus negative 2 is negative 4. Put it in parentheses, squared. And these two become plus plus because they're next to each other. So this becomes 7 squared. So I have 16 plus 49 for a total of 65. And all of these were still under the square root. I just wasn't writing them. So that's the square root of 65. And that's what we came up with over here. So the square root of 65 and the square root of 65. So using the formula, so please make sure you guys memorize this. Using the formula, you're simply going to subtract your x's and square them, and add to that subtracting your y's and squaring them, and then take the square root of all of it. The only difference, or the only thing that you need to watch out for is if we subtract our x's from 0.1 to 0.2, just make sure when you subtract your y's you don't reverse the order. I can't do negative 2 minus 2 and then flip-flop my y and say negative 3 minus 4. Okay? So if whatever stream you go, whatever direction you go in, you have to keep that same direction. So make sure if you're calling this 0.1, you're always starting with the x and y value here. Okay?